Yield in the name of love before you break my heart.
Mr. Sams, I think you need to keep your day job. Besides, you're not even singing the right words.
What do you mean?
Stop
Yield-
in the name of love. Stop in the name of love.
Okay, who's talking about keeping their day job?
But it's stop, not yield. But why are you saying yield?
Because I like to yield better. I don't have to come to a complete stop.
So okay, so you don't like to violate the rules.
I did get pulled over this weekend.
Did you?
I only got a warning, though. I was doing 68 and a 60.
Oh, ouch.
Yeah, it helps when your wife, she grew up with the officer's daughter.
Oh, yeah. Small
helps.
town world.
Yeah. Oh, well. I didn't get a ticket. It was about time, though. I haven't been pulled over in a while. I haven't had a ticket since I was 16.
There you go. So you are actually probably a pretty good driver, huh?
I'm not too bad. I don't.
So, hey, I guess we are talking about percent of yield. So maybe that's why you were saying stop in the name of yield or yield in the name, whatever that is.
Yeah.
I better keep my day job.
Yeah.
All right.
Percent yield. Then.
Percent yield. Not,
okay, yeah, percent.
Not yield in the name of love.
And this is it's kind of a different kind of yield. This yield is how much the reaction produces
as a percentage.
Right.
Yeah, so again, we've got a series of rules, so you got to just copy it down. Here's an equation. You may want to put this in the back of your comp book. It's kind of an important equation section.
Yep.
So, why don't you stop the video and write these down? Okay, let's do a
Did
couple
you hit
examples.
pause?
Hey, I bet you did.
If you didn't,
Stop, push pause again. All right, so here's a problem. Hey, we got a balanced. Is that balanced?
No. Yes, it is.
I think it might actually be.
It is. There's 11 carbons. Yep, it's balanced. Okay.
Okay, this is a 1-to-1 ratio. Okay, a student adds 200 grams of C7H6O3. Where did we get this problem?
I don't know. I didn't make it up, that's for sure.
Okay, all right. And what else do I know? I have 231 grams of aspirin. That's the C9 problem.
Yep.
So this is 231.0 grams of this.
That's how much is actually produced.
So what's the percent yield?
Right.
So this is what you're going to do. This is kind of weird. What you're going to do is you convert grams of this, of the reactant, to grams of the product.
Right. But we already have grams of the product.
Not really. What you've got is how many grams you actually made. This is your...
If I really did this in a lab, that's how much I actually
This
produced.
is how much you actually made.
So we need to calculate how much we could possibly make, or theoretically make.
Yeah, so what you do is convert that, and you're going to get a number larger than 231.
Hopefully.
Because you can never produce more than 100%.
Well, you can, but you didn't actually get the
You'd get
real
something
thing.
else,
It's like contaminated with a bunch of other junk.
Yeah. And then you're going to then divide. So this is actually a simpler problem than the limiting reactant problems that we did in the previous podcast.
I'll take it.
So I'll take 200 grams of C7
should probably add up that mass,
H6O3. I don't think I could do this in my 12, 7, 84. 84 and 6 is 90. 90 plus 48 is 138. Is that right?
Yes. Wow.
Grams of
I'm impressed.
C7H6O3. 138. Mr. Bergman is amazing. Okay, 1 mole of C7H6O3.
Write the thing out, people. No naked numbers.
Then I'm going to do the mole-to-mole ratio. This is an easy mole-to-mole ratio.
It's all 1
to 1. So 1 mole of aspirin. I'm going to call it ASP. That's the C9.
ASP. Yeah.
To 1 mole of C7H6O3. One thing cool about this reaction, just as a side note, guys, this is how you make aspirin, like that people eat, or not eat, they don't eat it, but they use it medicinally to cure their headaches and whatever. And then we'll say 1 mole.
My dad takes it for his heart.
Oh yeah, that's true. It's also good for people with heart issues. To so many grams of asp.
Oh, it's probably that
9
up too,
times
See if
12
you could beat me to it
is,
this time.
108 plus 8 is 116.
180. Beat you.
180. All right, I knew that. I didn't get there. All right, Mr. Bergman doing his head, and Mr. Sams beat me to it. So we now just do the math. The grams here cancel. The moles cancel. The moles here cancel, and you end up with grams. And you end up with a bigger number than 231. It is
261.
261 grams of aspirin.
Unless we want 4 sig figs. Do we want 4 sig figs?
You know, I think we should.
260.9.
260.9. That almost like I said 10. Okay. So I'm going to then take what I know. I actually made 231.0 grams of aspirin. And I'm going to divide it by 260.9 grams of aspirin. And I'm going to times it by 100. It looks like a pretty high percentage, 80s or 90s, Mr.
Yeah, we get 88.54.
88.54%. So that means that you are predicting you'd like to make 100% aspirin, but you only made 88.5, which actually
That's not too bad.
is pretty good.
Can I tell you a story?
Sure.
I made this when I took organic chemistry in college.
Yeah, I did
Only I
too.
knocked over my beaker.
Oh, yeah.
And we had to obviously calculate a percent yield. So most people were getting, 60 to 80% yield. I got a
10.
0.5
0.5
yield because everything came out
Nice.
except for like these 5 little drops on the bottom of my beaker.
Nice, 0.5% yield. I think I was in the 60 to 80%
Yeah.
when I did this
I
lab.
just-
It's
I'm
kind of a classic
I'm
lab
clumsy.
in college.
I knocked
Okay,
it
or
over.
AP chemistry too, or whatever. Okay, hey, same type problem, except we don't have a balanced equation.
Okay.
Some of you still, I bet, are still struggling with writing a balanced equation, and that's just part of it. You've got to go back and put your charges together, but you're going to get good at it because you're going to get to do it the rest of the year. Okay, so lithium. I have a lithium story. No, I don't.
No, you have a
Sodium?
potassium
No, it was lithium. A friend of mine.
Another.
He was an environmental.
alkaline metals.
He was an environmental engineer at Rocky Ford Nuclear Weapons Facility, and for some reason they used lithium in that process. And he was investigating the lack of lithium in their storage, and discovered that a couple of the workers had taken a big hunk of lithium, like this big, and thrown it into the lake.
Oh, but that's fun.
Yeah, and I guess it blew up, and it was very exciting, and they were bragging about it. Long story short, they got fired. So
Yeah, that tends to happen when you steal
basically
things from
steal
work and-
explosives.
yeah.
Lithium explodes, and like you steal explosives. Yeah, those guys lost their jobs. Okay, so he was telling me that story. They didn't like him for that. Okay, lithium. All right, so lithium is just Li. Reacts with copper 2 phosphate. So copper is Cu plus 2. The Roman numeral is the
Charge.
Always the charge.
Charge.
Phosphate. If you end in an 8 that's got some oxygen in there, that's a PO somebody.
PO4
4
minus
negative
3.
3. So when we put those together, that's a really weird one. Cu3 PO4 2. Now, it doesn't tell us. Well, actually, it does say. It says
single replacement
1.2 grams of copper is actually formed.
Okay, so that's product.
So we know
Cu.
it's going to be copper, but then it's going to get together with
Single
lithium.
replacement reaction.
So we have to write lithium and figure out his charge. His
Plus
charge
1.
is plus 1, reacting with a negative 3.
So we need 3 lithium.
So you say Li
3.
PO4.
Yeah.
Now we go back and we balance the equation. Complex guy is this one right here, so we'll leave him here. So let's do the copper first.
3.
Put a trace there. We got 2 phosphates, so if I put a 2 here, and this gives us 6 over here.
All right.
Now, what do we know?
We know 23.4 grams of copper 2 phosphate and 15.3 grams of lithium. Ooh!
15.3 grams here.
Interesting.
Oh, I know. I see. Did I throw this one at you, Mr. Sams?
23.4
23.4 grams. And we get 1.25 grams.
We have 2 reactants that both have a mass.
So,
This is a limiting reactant.
and a percent yield problem.
And a percent yield problem together.
So, guys, what we're going to do is convert grams of copper phosphate to grams of copper, and then grams of lithium to grams of copper.
Yep.
The lowest one will win, but then that will be the number. That number needs to be larger than 1.25. In theory, I guess it still could be. We could have more than
Yeah.
100%, but that's not going to
Usually,
happen.
yeah.
I think we're doing problems always like that.
Yeah.
And then we'll divide to find our percentage of yield. So we have to do a gram problem.
If you can do this problem, guys, you can do
Then you are
anything
amazing.
in this unit. You are good to go because you can write and balance an equation, you can do limiting reactant stoichiometry, and you can do percent yield.
Except for the molar mass one, but that's okay.
Well, that's coming
So
next.
grams of Li to 1 mole of Li, 7.
7.
Is it 7.0 or 6.9?
It is 6.941.
So we'll call it 7. No, 6.9.
6.94.
Well,
we want 3 sig
well, we just go to the 10th. of the
Okay,
decimal. And then we're going to say, what do we say? 6 moles of lithium to 3 moles of copper. And then we're going to say 1 mole of copper to 63.5.
Copper.
63.5
Yeah.
grams of copper. And I get what, Mr. Sams?
70.4.
70.4 grams of copper.
Okay.
All right, so now we're going to
Next.
take the 23.4 grams of Cu3. I'll write this 100 times. 4.2. I guess I wrote the problem. Okay. And then I'm going to say grams of Cu3, PO4, 2. That's going to be pretty complex in terms of its molar mass. You'll have 3 times 63.5 plus 2 times 31 plus 4 or 8 times 16.
Can you do that in your head?
I don't know.
380.5.
380.5. 0.05. I should have saved more space there. And then I want to say 1 mole of the Cu3PO42 to 3 moles of copper. One more step, and I'm going to say there are 1 mole of copper to 63.5 grams of copper. And this gives me what, Mr. Sams?
That is 11.7 grams.
11.7 grams of copper. Well, the lower number is 11.7,
Yep.
right? All right, so I'm expecting to make, here in my copper right here, I'm expecting to make 11.7 grams because that's the limiting reactant. But I
Yep.
only made 1.25 grams. Not a very good yield, really.
No, not at
So
all.
what would you do? Well, you'll take 1.25 grams divided by 11.7 grams times 100.
10.7.
Percent. The unit is percent on this one, okay? Okay, so if you can do these two problems, again, let's kind of go back and just do a quick review here. There we go. Okay, let me change the color of the pen. I think it will highlight it better for us all. If the pen would like to go in color, it's called red. Okay. You're going to convert the grams of the lithium, of a reactant, let's just say, to the grams of the product. If you've got 2 of them, you got to do both. The lowest one, which turned out to be the 11.7, it was the lowest answer. But then you take the amount that you actually got, and you divide it by the amount that you got, and then you times it by 100.
Yep.
That's how you do percent yield problems. Good? All right, we'll see you in class. And no more playing with the lithium or yielding. You need to yield more on your car, don't you? Is that what
I
you're
just need to slow down.
Just slow down. Yeah, that's probably too. All right, especially today. There's like ice on the road.
Uh-huh.